Right. So in the previous two videos, we discussed the basics of ratio as well as proportion. So let's continue with another topic, which is called variation. That's a very important topic because we'll find the application of this topic in the few topics like time and work and time, speed, and distance. Most of the questions of time and work and time, speed, and distance can be solved in 1 or 2 minutes using the concept of variation. Let's look at this concept. What does it mean? Variation. Fine. We also call it proportionality. It is also called proportionality. Now, what does it mean? What does it mean? If I say that with an increase in A, there's an increase in B also. Or maybe sometimes with an increase in A, there's a decrease in B also. So I can say that these two variables are related to each other. Now, what kind of relationship is there? Both of them are increasing together. So we call it direct. We call it direct relationship. And this is the inverse case. With an increase in A, there's a decrease in B. So we call it inverse relationship. Yes or no? Let's see how do we solve it. Two quantities are said to be directly proportional if the ratio is constant. Now, if it's given that with an increase in A, there's an increase in B, or with a decrease in A, with a decrease in A, there's a decrease in B. So I can see that they are directly related to each other. So how do we write it? We'll say that A is directly proportional. This is called proportionality sign. A is directly proportional to B. And when we remove this proportionality sign, we introduce a constant Ka. So what do we get here? A by B is equal to K. So whatever may be the value of A, whatever may be the value of B, the ratio will always be constant. Now, this concept can be used in the questions like this. If I've got set of values of A1 and A and B, we can relate it like this. A1 by B1 must be equal to A2 by B2, must be equal to A3 by B3, and so on. And so on. Fine. So this happens when the variables are what? Directly proportional to each other. So we write that the ratio is always what? Constant. Let's look at an example here. If you talk about, let's say, speed and distance, can we say speed is directly proportional to what? Distances to be traveled in a constant time? Yes or no? Let's say one day I traveled with a speed of 50 kilometers per hour and I covered 100 kilometers. Next day, my speed became 75 kilometers per hour. So, in the same time, how much distance will be covered by me? Now, we know that speed and distance are directly proportional to each other. So, how do we write it? S is equal to K into D, or K becomes what? S by D. And what was the value of speed in the first case? It was 50. What was the distance? 100. Next time, speed became 75. Distance is not known to me. When we equate them, we definitely get the value of D2. It comes out to be 100 into 75 by 50. Yes or no? This gives you 150 kilometers. Now, you have increased your speed by 50%. That's why the distance will also increase by 50%. This is how we can solve the question of variation. Fine. Now, let's look at one more concept. If two quantities are said to be inversely proportional if their product is constant, why I am saying like this? A is inversely proportional to B. When does it happen? If I say that with an increase in A, there's a decrease in B, or with a decrease in A, there's an increase in B. So I can see the inverse effect here. How do we remove this proportionality sign? By introducing a constant K. So what do we get here? K is equal to A into B. That's why if two variables are inversely proportional to each other, the product will become constant. So how do we write it? A1 B1 must be equal to what? A2 B2. So the product of those two variables will be what? Constant. Let's take an example. When you talk about men and days, Men and days. What's the relationship between them? If the work is constant, can we say more the number of men, less the number of days are required? Or the reverse is what? Less the number of men, more the number of days are required. So let's take a case here. 50 men can finish a certain piece of work in, let's say, 25 days. Fine. Now, my question is, in how many days 60 men can finish the same piece of work? Now, this value is missing. And we know that men and days are constant, and whenever two variables are constant, the product has to be constant. So, how do we write it? M1 D1 must be equal to what? M2 D2. Men in the first case were 50, days were 25. Men in the second case are 60, days are missing. So this will give you T2 is equal to 50 into 25 by 60. 0 will be cancelled out. You get 125 by how much? 6. So these many days are required to finish the work. This happens when the variables are what? Inversely proportional to each other. I hope this is clear. Let's so the product has to be what? Constant. Let's take one more case here. If A is directly proportional to B while C is a constant, and A is directly proportional to C when B is a constant, how do we write it? We'll say that A is proportional to B and C both. Yes or no? This is how you can use this, and this is called joint variation. We call it joint variation because I'm going to connect what A with B and C both. So it works for direct variation as well as inverse. Let's take an example here. We know that speed is equal to distance upon time. So can we say speed is directly proportional to distances to be traveled if time is constant? Yes or no? If the time is constant, I can say that speed is directly proportional to what? Distances to be traveled. What if I say that speed is inversely proportional to time taken when the distance is constant? So I can see two relationships here. S is directly proportional to D and inversely proportional to T. So how do we write it? S is proportional to D and T both. D is direct and T is what? Inverse. Now this can be written as S is equal to K into D by T, where K is a constant. So I hope these three variations are clear to you. In case of direct variation, the ratio will be constant. In case of inverse variation, the product will be constant. And the joint will work according to what direction, direct and inverse. Now, sometimes what you'll see, there'll be a case when the quantity, total quantity, will depend on what? Sum of fixed and variable parts. Let's say electricity bill. The total bill will depend on the fixed charges and the variable charges. Now, what are the variable charges here? We know that the variable charges will be directly proportional to what? Number of units to be consumed. So how do we write it? Variable charge would be equal to K into N. So the equation will become total electricity bill will have some fixed charges plus variable charges, which can be written as K times of N. This can be one of the examples of what? This special case. Now let's look at few questions here. And we'll talk about the approach also. For a body starting from rest, fine. The distance traveled is directly proportional to the square of the time elapsed from the start. Now, what's given here? Distance is directly proportional to time square. So, can we say t is equal to kt square? Yes or no? We can say that t is equal to what? Kt square. Now, do we solve the question? Look at the data given here. If a body travels 48 meter in 4 seconds, it travels 48 meter in 4 seconds, then find the distance traveled by the body in 7 seconds. Let's look at the first case, equation based approach. How do we solve it? Distance is given equal to 48 is equal to k into what's the time given here? 4. I'll put 4 here. After solving this, what do you get here? 48 by 4 square is equal to k. 4 square is 16. So I can say that k must be equal to how much? 3. And we know that k is a constant. It will always be equal to what? 3 in this particular case. Now, what's the next part of the question? Find the distance traveled. We know that distance is equal to how much? K into t square. K, we know the value. That is 3. What's the time given? 7. So t becomes 7. 7 square is 49. 49 into 3 is how much? 147. So this would be the distance traveled by body in 7 seconds. This is called equation based approach. If you don't want to solve it like this, there's one more way, the constancy based approach. We know that if two variables are directly proportional to each other, then the ratio has to be constant. That is d by t square must be equal to k. So the first condition, let's say d is d1, time is t1. Next time, distance is d2, time is t2. Let's put the values here. First case, distance was 48, time was 4. Second case, distance, I don't know, but the time given here is 7. After solving this, again, we get d2 equal to how much? 147 meter. So in this case, we'll have to calculate the value of k. And here, you don't have to calculate the value of k. You can just equate the variables. Fine. Let's look at one more question. What's given here? A fort has a provision for 90 days. What does it mean? I have food for 90 days. For how many people? I don't know. But we know that men and days are what? They're inversely proportional to each other. That's why the product of men and days should be constant. Now, initially, how many men were there? I don't take it equal to n. The food will last for how many days? 90. So men are n, days are 90. N people can have food for 90 days. They started it, they had the food for how many days? 26. So I got n into 26 here. Next time, 500 people will increase it. So I'll multiply it by 500. They can have the food for how many more days? Now the food now lasts for only 48 more days. That means this group can have the food for 48 days only. Yes or no? This is one equation, one variable. We'll get the value n from here. This is 90n is equal to 26n plus 48n plus 48 into 500. That is 24,000. Yes or no? This 26 plus 48 will give you how much? 74. 74 comes on this side. You get 16n. 16n is equal to 24,000. So you get n equal to how much? 24,000 by 16. This is 8 into 2, 8 into 3. Effectively, you get how much? 1500. That means the food was there for 1500 people. And in that case, it would last for only 90 days. But if we increase the manpower after some days, obviously now the food will not last for 90 days. The days will decrease, which is equal to how much? 84. Let's look at this case now. I was talking about that bill. Look at this. The monthly boarding expenses of a hostel is partly fixed and the remaining part varies directly with the number of boarders in the hostel. So can we say the total expenses of the hostel will be what? A sum of fixed charges and variable charges. And varies directly with what number of boarders? It depends on the number of boarders. So how do we write it? This variable charge will be directly proportional to number of boarders. That's why variable charges can be written as k into n. Fine. Now let's look at this equation. Total expenses is equal to fixed charges plus k times of n. Now what are the total expenses here? It's given that the average expenses per boarder is 700 when there are 120 boarders. So this can be written as 120 into each and every one will be paying 700. So these are the total expenses which will be split into two parts like this. Fixed charges plus k into how many people are there? 120. This is case number one. What's the case number two? They'll be paying 680 rupees each when the number of boarders are 150. So the total expenses will become 150 into 680. which is equal to fixed charge that will remain same plus K into 150. This is equation number 2. I can see two variables here. One is FC and one is K. Take the difference of these two equations. FC will be cancelled out. Yes or no? 150K minus 120K will give you how much? 30K. And on this side, I'll get 120 into 700. This will be minus sign. 150 into 680. So what's the value of K? You get 150 into 680 minus 120 into 700 divided by how much? 30. I can easily take how much common from here? 100 common. So after that, I'll be left with 15 into 68 minus 120 into 7 divided by 30. This will give you the value of K. This is equal to how much? This gives you, when you solve it, you get 600. So the value of K is 600. I'll put it here to get the value of FC. So this was equal to 12 into 700, that is 84. You get three zeros here. Minus K was how much? 600. 600 into 120 is 72,000. This is equal to fixed charge. So what are the fixed charges here? I can say 12,000. Yes or no? So I got the value of fixed charges as well as K. What's the question now? What is the total cost? Find the average expenses per boarder when there are 200 boarders. So what I'll do, I'll put FC equal to how much? 12,000 and K equal to how much? 600. So what do we get here? Let's look at this one. Total expenses will be equal to fixed charges, that is 12,000 plus K is 600, and the number of boarders are how many? 200. 600 into 200. This is 12,000 plus 12, and you get four zeros in. This would be the total expense. But what he's asking, the average expenses. That means this value has to be divided by how much? 200. So this 12,000, this is 1,20,000. That makes 1,32,000 by 200 boarders. So let's divide it by 200. Zeros will be cancelled out. And how much do you get here? 660 rupees. Now the expenses will be 660. Fine.